Hello everyone, I am Isha Kumari from Sri Venkateshwara College of Engineering, Bangalore, and here is a presentation on database management system. The topic for today is understanding constraints in DBMS. So, introduction to DBMS. What is a DBMS? A database management system is a software system that allows users to define, create, maintain, and control access to a database. It provides an interface for interacting with the database and ensures data integrity, security, and efficiency. Importance of DBMS. DBMS plays a crucial role in managing data in organizations as it allows for efficient storage, retrieval, and manipulation of data. It provides a centralized and structured approach to data management, enabling multiple users to access and share data simultaneously. Types of constraints. In database management system, constraints are used to enforce rules and restrictions on data stored in database tables. These constraints help maintain data integrity and ensure that the data meets certain criteria. There are several types of constraints that can be applied to database tables. Types of constraints. Primary key. A primary key constraint is used to uniquely identify each record in a table. It ensures that the primary key columns have unique values and cannot be null. Foreign key. A foreign key constraint is used to establish relationships between tables. It ensures that the value in a foreign key column match the values in the primary key column of the reference table. Unique. A unique constraint ensures that the value in a columns are unique and cannot be duplicated within the table. Unlike a primary key constraint, a unique constraint allows null values. Check. A check constraint is used to specify a condition that must be met for the data in a column. It allows you to define custom rules and validate the data against the rules. Not null. A not null constraint ensures that a column cannot contain null values. It enforces the equipment for a value to be present in the specific column. Default. A default constraint is used to provide a default value for a column. When no value is specified during an insert option, it assigns a predefined value to the table other value is provided. Primary key constraint. A primary key is a column or a set of columns in a table that uniquely identifies each record in the table. It ensures that each record in the table has a unique identifier, which is crucial for data integrity and efficient data retrieval. Examples of primary key constraints. In a table of employees, the primary key could be the employee ID. In a table of products, the primary key could be the product code. In a table of students, the primary key could be the student ID. Now, foreign key constraint. What is a foreign key? A foreign key is a column or a set of columns in a table that refers to the primary key of another table. It establishes a relationship between two tables, allowing data to be linked, shared between them. How is it used? Foreign key constraints are used to enforce referential integrity in a relational database. They ensure that the data in the referencing table, also known as the child table, corresponds to data in the referenced table, also known as the parent table. This helps maintain data consistency and prevents orphaned records. Examples. Here are a few examples of foreign key constraints. In a database for an online store, the orders may have a foreign key column customer ID that references the customers table. This establishes a relationship between orders and columns, allowing each order to be associated with a specific customer. In a database for a university, the courses table may have a foreign key column department ID that references the department's table. This establishes a relationship between courses and departments, allowing each course to be associated with a specific department. Now, unique constraint. A unique constraint is used to enforce the uniqueness of values in a column or a combination of columns in a database table. It ensures that each value in the specified column is unique and does not appear more than once. Unique constraints are commonly used to enforce data integrity and prevent duplicate entries in a database. They can be applied to single column or multiple column, known as composite unique constraints. Example of unique constraints: email address ensures that each user in a database that has a unique email address. Employee ID ensures that each employee in a company has a unique employee ID. Username ensures that each user in a system has a unique username. ISBN ensures that each book in a library has a simple and unique ISBN number. Not null constraint. The not null constraint is used in a database management system to enforce that a column cannot contain null values. This means that when a record is inserted or updated, the specified column must have a value and cannot be left empty. The not null constraint is commonly used to ensure data integrity and prevent the insertion of incomplete or missing data. Example: consider a table called employees with the following column: employee ID, integer, first name varchar, last name varchar, email varchar. To ensure the not null constraint on the first name column, the table definition would include the following: create table employees, employee ID int, first name varchar, not null, last name varchar, email varchar. In this example, any attempt to insert or update a record without providing a value for the first name would result in an error. Check constraint. A check constraint is used to enforce a condition on the values in a column. It ensures the only valid data is inserted or updated in the column. The condition can be any logical expression that returns a Boolean value. Example 1: age limit. To enforce an age limit of 18 years or older, you can use the following check constraint: alter table users add constraints age limit check age is greater than or equal to 18. This constraint ensures that the age column in the user table only contains values that are greater than or equal to 18. Example 2: email format. To ensure a specific email format, you can use the following check constraint: alter table employees add constraints email check, email format check, email like these signs. This constraint ensures that the email column in the employee table only contains values that have the @ symbol and at least one dot symbol. Default constraint. A default constraint is used in a database management system to provide a default value for a column when no value is specified during the insertion of a new arrow. Of a new row. This ensures that the column always has a value even if it is not explicitly provided. Default constraints can be defined when creating a table or added later using an alter table statement. Example: consider a table called employees with columns employee ID, first name, last name, and salary. If a default constraint is set on the salary column with a default value of 50,000, then whenever a new row is inserted into the employees table without specifying a value for the salary column, it will automatically be set to 50,000. Create table employees employee ID int primary key, first name varchar 50, last name varchar 50, salary decimal 10, 2, default 50,000. In this example, if a new row is inserted without specifying a value for the salary column, insert into employees employee ID, first name, last name, values 1 John Doe. The salary column will automatically be set to 50 for this new row. Default constraints are useful when you want to ensure that certain column always have a value explicitly provided during data insertion. Constraints in practice. Implementing constraints. Constraints in a DBMS are rules that define and enforce the integrity and consistency of data. They can be implemented through various mechanisms, such as primary key constraints ensure that each record in a table has a unique identifier. Foreign key constraint establishes a relationship between two tables, ensures referential integrity. Unique constraint ensures that a column or set of columns in a table contains unique values. Check constraint defines a condition that must be satisfied by the values in a column. Examples of constraint usage. Constraints can be used to improve data integrity and consistency in various ways, such as ensuring that each customer record in a database has a unique customer ID, enforcing referential integrity by ensuring that a foreign key in one table references a valid primary key in another table, restricting the values that can be stored in a column, such as allowing only positive integers or valid email addresses, enforcing business rules such as ensuring that a product's price is greater than 0. Conclusion. Importance of constraints in DBMS. Constraints play a crucial role in ensuring data integrity and consistency in a database management system. They enforce rules and restrictions on the data, preventing the entry of invalid or inconsistent values. By maintaining the accuracy and reliability of the data, constraints contribute to overall quality and usability of the database. Future trends and advancement. As technology continues to evolve, so does the management of constraints in DBMS. Some future trends and advancement in constraints management include automation of constraints creation and enforcements, integration of machine learning algorithm for intelligent constraint handling, enhanced support for complex data relationships and dependencies, real-time constraint monitoring and analysis. Thank you.